In this video, I will explain the basic concepts that the basic in interaction allowed by the VOCIS 3D graphical user interface. The the interface mainly consists of a 3D model of the interconnect that we want to simulate, and then we have a progress bar below and a legend with the list of colors which we'll see will be necessary. So as for most 3D models, it's possible to zoom in and out of the model, to pan it as well, to select only the part of the interconnect which is interesting us. Then we have three different view modes. One view mode with only the outline of the routers, blue cylinders, the network interface circuits in green, the squares, and the channels in white, which include the link, the input buffer, and the output buffers. Then we have the internal mode, the content mode, which shows the actual state of the interconnect in terms of fleets and router state. We'll come to this a bit later. And finally, we have a third mode which combines the two previous, which gives us all the information we want to know about both the load, the defects of the resources, and the internal states, but at the cost of some more of many displayed elements. So to detail a bit how the traffic is represented in the VOCIS graphical user interface, we believe that it's important to represent two things when we want to talk about the wormhole routing. The first thing, of course, is the fleets which are progressing through the channels. Okay, so for each channel, which again include the associated output buffer, link, and input buffer, we represent the wall by a solid, which includes several virtual channels. Which may include several virtual channels. Then, if we consider the input buffer from the network interface channel, which consists only of one virtual channel, we see here colored that the solid has been colored in different colors in order to indicate that we have a head fleet in brown, payload fleets, and if we let the simulation move forward, we see all the fleets also coming, and in yellow the tail fleet coming. We also have in orange the acknowledgement fleets. Then the second point, then for channels which include multiple virtual channels, we see that the solid is divided into different lines, which each correspond to one virtual channel. The second important point for representing the wormhole routing is the router internal state, that is, which input virtual channel has logged which output channel of the router, and this is represented by the blue rows that you can see here, which allow us to easily represent the fact that when a fleet